When it comes to the detailed nature of black holes, it would not surprise me if we got it all wrong.
Even though you can't see the black hole itself, it's going to leave behind a trail of destruction, and that is something you can see.
The most powerful telescope ever created, none other than the extraordinary James Webb Space Telescope, has unleashed an earth-shattering revelation that will leave you questioning everything about our place in the vast expanse of the universe. Are you ready for this? It turns out that our humble Earth is not confined to a mere corner of space, but resides within the mind-bending confines of a colossal black hole. How did this revolutionary space observatory come to such an astonishing conclusion? And what does it mean for the boundless field of astronomy? Join us as we take a deep dive into the awe-inspiring findings of the James Webb Space Telescope, unraveling the shocking truth that our very existence is intricately entwined within the mysterious depths of a black hole. Black holes, areas in space where gravity reigns supreme, possess such immense strength that even light cannot escape their clutches, rendering them invisible to our eyes. However, we can unveil their presence through the impact they have on the matter surrounding them. In certain cases, these enigmatic entities boast swirling disks of swiftly rotating gas and dust, emitting a dazzling display of radiation known as quasars, which rank among the most brilliant celestial objects in existence. But how do these perplexing voids come into being? Well, their formation hinges on their size and origin, giving rise to various types of black holes. Among the most prevalent are stellar black holes, forged from the demise of massive stars that implode under the weight of their own gravity. While their mass can reach up to 20 times that of our Sun, their dimensions span only a few kilometers. Yet there also exist colossal and exceedingly rare supermassive black holes, titanic behemoths harboring millions or even billions of solar masses and extending millions of kilometers across. These gargantuan entities frequently occupy the central cores of galaxies, including our very own Milky Way. Although the precise mechanisms governing their formation remain elusive, scientists theorize that they may have emerged from smaller black holes merging with one another or with stars over the course of cosmic history. And now what's truly remarkable is the latest mind-boggling revelation by the JWST. A colossal cosmic entity, a black hole that surpasses the Sun's weight by a staggering factor of 10 million. However, its immense size is not the only astonishing aspect. It also holds the distinction of being the earliest black hole ever detected in the universe. Positioned at the heart of a youthful galaxy, this supermassive black hole, with a mass of 10 million times greater than that of the Sun, was unveiled by the JWST's remarkable cameras, granting it the ability to peer back in time in the nascent stages of our cosmic existence. This cosmic behemoth could be one among countless black holes that indulged in cosmic feasts, leading them to attain colossal proportions during the cosmic dawn, an era commencing roughly 100 million years after the Big Bang and spanning a billion years. The abundance of these black holes and the means by which they achieved such immense sizes remain mysteries that confound astronomers. While this discovery represents the lone specimen we have found at this particular redshift, denoting a point in time post-Big Bang, it is anticipated that many more exist. Scientists posit that this black hole didn't form recently, implying the existence of younger counterparts that emerged earlier in the timeline of the universe. Black holes form through the gravitational collapse of massive stars and perpetually grow by devouring gas, dust, stars, and even other black holes. The ensuing friction propels the consumed matter into swirling spirals within the insatiable fabric of space-time, generating intense heat. This process gives rise to luminous emissions observable by telescopes, transforming these black holes into what is known as active galactic nuclei, AGN. Among the most extreme manifestations of AGN are quasars, colossal entities billions of times more massive than the Sun, illuminating the cosmos with light bursts surpassing the brilliance of even the brightest stars trillions of times over. Due to the constant speed at which light traverses space, delving deeper into the universe allows scientists to intercept light from increasingly distant sources, granting them glimpses further back in time. Astronomers meticulously scan the heavens employing two infrared cameras, the JWST's mid-infrared instrument and the near-infrared camera, then employing the camera's built-in spectrographs to disentangle light into its constituent frequencies, aiding in the quest for black holes. Within this journey, they stumbled upon an unexpected augmentation in the frequencies contained within the light. By meticulously analyzing these faint glimmers that have traveled across the cosmos since its formative years, they stumbled upon a crucial clue: a subtle trace of radiation emanating from the heated material encompassing a black hole, disseminating throughout the vastness of the universe. The sudden emergence of black holes in our nascent cosmos remains an enigma. Astronomers tirelessly persist in their search, eagerly seeking even younger, hypothetical primordial black holes that materialize in the aftermath of, or possibly even before the Big Bang, as suggested by certain hypotheses. However, these elusive entities continue to elude our grasp, preserving their mysteries within the fabric of the universe. Before this remarkable discovery, the JWST captured the emergence of two galaxies encircling an enormous black hole. The amalgamation of galaxies was detected as they merged around a unique red quasar, a voracious supermassive black hole that voraciously devours gas and other celestial matter. The JWST's multinational team of scientists achieved this awe-inspiring breakthrough by peering back billions of years into the past. This discovery offers insight into early galactic collisions that shaped our present-day cosmos. The researchers describe the SDSS-J165202.64 plus 172852.3 quasar as an astonishingly bright and deeply red object, over 11.5 billion years old. It is among the most powerful quasars ever observed, providing valuable information about black holes. Excitingly, these systems are on the brink of significant changes, with the galaxy undergoing a transformative phase that will drastically alter its appearance in billions of years. Initially, the Hubble Space Telescope and the Gemini North Telescope in Hawaii spotted the quasar and suggested the presence of a transitioning galaxy. However, subsequent JWST observations revealed not just one, but at least 3 galaxies swirling around the quasar. But what is truly astonishing about black holes is the claim made by some scientists that we actually exist inside one. Let's take a journey back in time. Prior to the existence of humankind, the formation of Earth, the ignition of the Sun, the creation of galaxies, and the birth of light, there was the Big Bang, a momentous event that occurred approximately 13.8 billion years ago. But what about before that? According to numerous physicists, there was nothing preceding it. They argue that time began ticking at the precise instant of the Big Bang, and consider anything prior to that is deemed unscientific. As humans, we can never comprehend what reality was like before the Big Bang, its fundamental composition, or the catalyst behind its explosive emergence, as these concepts transcend our understanding. However, dissenting from this conventional viewpoint, some audacious scientists propose an alternative perspective. They posit that preceding the Big Bang, all the matter and energy of the embryonic universe were densely compressed into an unimaginably compact yet finite entity, a seed of a new universe. This seed, though infinitesimally small, potentially trillions of times tinier than any particle known to us, possesses the power to initiate the creation of every other particle, as well as galaxies, solar systems, planets, and even individual entities. If we were to designate something as the God particle, this seed stands as an exceptionally compelling contender. So, how does the genesis of such a seed occur? Recently, Poplawski from the University of New Haven proposed a theory after these discoveries by the JWST, suggesting that our universe's foundation took shape in an extraordinary crucible, the most extreme environment in nature, the core of a black hole. Before delving deeper, it is vital to acknowledge that numerous theoretical physicists now contemplate the possibility of our universe being just one among many. Together, these distinct realms form the multiverse, each adorned with its own radiant celestial body adorning the genuine nocturnal expanse. The interconnections between universes, if they exist at all, remain a matter of intense speculation and conjecture, devoid of tangible evidence. However, one captivating hypothesis likens the birth of a universe to that of a plant's seed, a condensed, crucial element nestled within a protective casing, analogous to what transpires inside a black hole. Black holes manifest as remnants of colossal stars. When such a star exhausts its fuel, its core implodes, succumbing to gravity's relentless and ever-escalating grip. The temperatures skyrocket to a staggering 100 billion degrees Celsius, atoms shatter, electrons disintegrate, and these fragments endure even further compression. At this juncture, the star has transformed into a black hole, a celestial entity with gravitational pulls so formidable that light itself cannot escape. The event horizon delineates the boundary between the inner and outer realm of a black hole, and these massive cosmic entities, some millions of times more massive than the Sun, have been detected at the center of virtually every galaxy, including our own awe-inspiring Milky Way. Now, utilizing Einstein's concepts to calculate the phenomena transpiring within a black hole's depths yields an infinitesimally small and infinitely dense entity, a theoretical construct known as a singularity. Nevertheless, such infinities are rare in nature. This discrepancy arises due to the limitations of Einstein's ideas, which offer remarkable explanations for the majority of the cosmos, but stumble in the face of colossal forces like those within a black hole or during the birth of our universe. According to physicists like Dr. Poplawski, matter inside a black hole can only compress to a certain extent. This seed, albeit weighing as much as 1 billion suns, maintains its tangible existence, unlike a singularity. Dr. Poplawski argues that the compression process halts when black holes start spinning. Rapidly rotating at dizzying speeds, possibly nearing the velocity of light, this rotation endows the compacted seed with immense torque. Thus, not only is it small and massive, but it also twists and squeezes akin to those comical spring-loaded snakes in a can, which unpredictably unspring with a resounding bang. That is the Big Bang, or as Dr. Poplawski refers to it, the Big Bounce. In essence, a black hole may serve as a conduit, a one-way gateway, as Dr. Poplawski articulates, between two universes. This implies that if one were to plunge into the black hole situated at the center of the Milky Way, they, or the shredded particles that once constituted their being, might find themselves in another universe. Dr. Poplawski clarifies that this alternate universe does not reside within our own. The black hole merely acts as a link, a shared route connecting two separate paths. But what about the remainder of us residing in our universe? We could potentially be the progeny of a previous cosmos, akin to our mother galaxy. The seed of this mother universe might have undergone its monumental bounce 13.8 billion years ago. And despite our universe's rapid expansion since then, we might still remain concealed behind the event horizon of a black hole.